So unless you've been living under a rock, you've probably known just how crazy busy this year has been for AI and robotics, especially humanoid robots. It's really hard to keep up with every new startup, every new bot unveil, be it from China, Europe, and of course, America. We do our best here on Over the Horizon, but it's also great to have the likes of Mehrdad Farimi and his fabulous compilations on all things robotics. Mehrdad is the CTO of MERPHI, Sweden's leading robotics design consultancy, and they become famous for their beautifully curated robot posters tracking every humanoid, quadruped, and cobot across the industry. Also with me, Scott Walter and Gustav Andersso. Scott, as you know, is a mechanical and aerospace engineer and two-time founder of robotics companies. And for those who follow us closely on Over the Horizon, Gustav is a hand surgeon, associate professor of anatomy in northern Sweden. Welcome, gentlemen. Lots to talk about today.
Hello, Rock. Hello, Scissors.
Who would want to live under a rock?
Yeah. Mehrdad, it's always good to see you again.
Yeah.
We need to find a name for Mehrdad.
You already told me. Let me bring this.
Oh yeah, he was the rubber
band. Yep.
Oh yes. Yeah. Oh yes, absolutely.
Either rubber band or duct tape. I think that's the only thing left. Right?
Good one.
Or maybe crazy glue. He's the crazy guy that keeps us together.
Yeah. Crazy glue. I like it. All right. So Mehrdad, you've got a lot to take us through, all these lovely posters of yours. Let me just quickly bring them up on the screen and please take us through them.
Absolutely. Thank you very much, Ridin. And so, yes, I want to tell you a bit of story and backgrounds and show you some of the posters we've created so far. These are just some of them that are public. There are some more that are not public. And yeah, I hope I can, if we have time, we can show some of those. So this is the first poster that we created back in 2023. It was early 2023. I remember the planning was in 2022. Probably, yeah, same time of the year as now. And then the idea came from, like, whenever we design a robot, we look into a lot of different robots, and we try to do competitor analysis and market analysis and so on. And we were designing actually two of these robots at the same time. And then we had all these different robots that were in the market so far beside each other. And then I thought with my colleagues, what if we just publish this? People might like it, actually. So we did that very quickly, and this was the first draft. So as you can notice here, that Atlas Electric was not still published back in that time. Mm-hmm. And but how crazy the market grew, and that's what we could see in these posters, and that's what people usually liked about them. So this
is updated till the latest, till this year.
Oh, no. This was the first poster that we published back in that time. It's a very old one. And then we have the second one, which is this one in 2024. This was also early 2024. And then we had a few updates. And if we want to compare, for example, we can see that Figure had a closed on, Optimus kind of changed. Then, of course, Atlas changed quite a lot. Unitree have their small version. Fourier had a better close on, and so on and so forth. I think also Neo. Yes, Neo was still actually it was called Eve, the wheel-based one. And then now we got so much progress here, only in 1 year. But then people were complaining that, oh, where's our robots? And usually that's the case. Like they just comment. We are mostly active on LinkedIn, so most of the people are following up there. And people were complaining, oh, where's our robot? There are also this robot or that robot. So we thought, let's also focus on some other robots that we can have them in the area of research, social, and entertainment. So as you know, research has been the biggest area for robotics, right? We have a lot of research robots, and then we have a lot of interactive robots and companion robots. So we try to include them also. This part didn't have as much progress as the industrial robots, basically. Mm-hmm. And then there was also
like the Swedish one. If you go back, the one with 0 degrees of freedom. Why bother about actuation when you just have the head?
That is very true, and but love the people.
But I also suspect that as the industry evolves, you're going to see more and more of bots for companionship and entertainment and these sort of roles.
Absolutely. That's one of the areas of robotics
As
that
they become more human-facing rather than production-facing on the factory floors.
Exactly. So again, like you can categorize them based on application or based on the system or based on how many degrees of freedom they have. But we have different ideas of how to categorize it. And then by the beginning of 2024, there was a boom in quadrupeds. And this poster for me at least is very important because if you look at it today, they haven't improved so much. This is end of 2023 and beginning of 2024. And so far, we are almost 2026, and we don't see many more quadrupeds besides what we had here, which was, again, back in 2024. So this was interesting.
Why is it? Is it because the platform has kind of evolved to a point and there's the next iteration doesn't really bring about that much of a jump in value addition?
That's a good question. We looked into it and we talked to a few people quite a lot. And what we kind of realized was that the market that quadrupeds were targeting was not really a market that can justify the price of these units. For example, a Boston Dynamics Spot, it costs something around 100,000 euro. And then we have cheaper versions with Unit 3, which was adapted quite a lot. But at the same time, people couldn't really figure out what the actual application of it would be. The actual application of quadrupeds was inspections in construction, in unstructured environments, and so on. But it was not a very high adaptation there. Also, we had entertainment quadrupeds, but they were just very expensive toys.
Yeah.
And that was
the AI.
Scott, didn't you run across?
Well, I mean, since I guess these are more or less teleoperated, or you have to give them a certain task. They would just not. If you would have one as a guard dog, you would really have to program it quite thoroughly. It's not just a one size fits everything.
Absolutely, that's one thing. The other thing is that actually most of these companies, the Chinese ones who are building these platforms, they just give you a quadruped. And if you want to include a LiDAR, then it's more expensive. If you want to include a smarter camera, more expensive. And if you want to include those AI part, like proper image processing and large behavioral models, that would be a different project by itself. So they don't take the responsibility there, except some of them. For example, Robotics they created the quadruped for inspection. They have been around for many years. I think like up to 20 years since their first version. But
doesn't SpaceX have a couple of quadrupeds? Scott, did you run into any in one of your many visits?
No, I didn't personally, but I think I have heard of it, that usually after the launch or something, it'll run around and inspect to make sure the area is safe.
Right. Are those Unitary bots, or are they Boston Dynamics?
I'd have to double check. I think they were probably either Boston Dynamics or AnySim. I'm not sure which. Or not AnySim, that AnyBot, AnyMal.
Right. Mehrdad, I see that you've not included any of the quadrupeds that are being deployed for military purposes.
Well, we have Ghost Robotics here. This was.
Right.
Yeah, Ghost Robotics was.
Ghost is an American company, right?
Yes, exactly.
Okay.
Yeah. And I think they're still active, but I'm not hearing much from them. The other thing is that usually the ones I've seen about military purposes is that the ones that are just, I don't know, a Unitary or a deep robotic being repurposed for that.
Yeah, I think the Chinese are pretty big on deploying quadrupeds for patrolling and putting
LMG. It was Boston Dynamics Spot, and they called it Zeus. It was
cool.
Zeus.
Nice name.
Nice
but
name, yes.
To be honest, one thing I also said before in when we were talking to Marwa and Scott is that one thing we should never forget about robotics, and it's that most of the robotics form factor were a mean to study biomechanics. So the reason that quadrupeds were created from the beginning was to research and study on biomechanics. So the point was not really the application. They were not the products who were built for a certain application. They were just a product that were capable of different features. And then one thing that it's a saying in robotics, and it's pretty funny, it usually says, robotic is a solution that is looking for problem. And
Always.
I think we can see them at its best on Quadrupeds. But
Yeah.
well, I mean, actually, after this poster, I realized I saw a patent very randomly from Lenovo that they have a quadruped with 6 legs, and I think I have it in one of the posters. So they even went there. The only improvement that we saw from quadrupeds since 2020, end of 2023, was that most of these companies started to put wheels on their quadrupeds. You've seen these wheel-based quadrupeds that are very agile, doing crazy things. Yet, I don't think if they could solve the problem of application. So that was mostly the point. Yeah, I can continue here. So
Well, can we
yeah.
just go back, because I have a couple of questions, because this form factor has fascinated me, but we don't always get an opportunity to talk about it in detail on Over the Horizon.
True.
And one of the main purposes that I see is not only for military, but also for search and rescue, for cargo, for various purposes. We've seen, Scott, correct me if I'm wrong, we've seen DARPA play around with this form factor for quite a while for military logistics and transport. And I guess this is about 10 years back or so, if my memory serves me right. But I would like to kind of pick your brain, Scott and Mehrdad, on what really is a limiting factor in a wider deployment and wider range of applications for this form factor. Why are we not seeing? Because, I mean, if you look at it, the quadruped is a lot more stable than a biped. It can possibly carry a phenomenally bigger load than a biped can. These are assumptions, but fact check us. What's going on? Explain it to us.
How big is the market for fire trucks?
Specific use case based, but
Yeah.
trucks in general, quite big.
Yep. Yeah. And I think that might be part of it. If search and rescue is one of those things we hope we never need them for, right? And so it's kind of the rarity. It may be very difficult to scale in there. That might be one of the reasons. So it's a niche use case, and no one's been able to figure out what's the niche outside of that. And a lot of it, your wider niche would be more in construction kind of applications of inspection on this construction site to make sure everything's going on. Maybe playing the role of a building inspector. I can see that because construction is something we do a lot of, and hopefully the buildings just don't fall down that we require the search and rescue.
Yeah, even installations like oil and gas, drilling, etc. Wherever you have large installations, wouldn't it
I
be
can share some experience here. Not much of speculation, but I think Scott is totally right about the niche application. One thing I can say is that back in 2023, I co-founded a company called Norsense, and this company's purpose was to do construction inspection from remote distances. And we had a very solid use case. We had a very solid business plan and business model. So we were contemplating on the platform. And well, it was a bit early for us to adapt to Quadruped back in that time, but we started looking into it. There were 3 main issues with quadrupeds in construction. One of them, at least back in that time, was the runtime. So most of them, the maximum battery hour was 2 hours, or maybe less than 2 hours. So in a construction work, we often expect, at least in our use case, we expected 6 to 8 hours of battery runtime for a shift of working, which is 8 hours. And it was not fulfilling that. The second point was that in construction, you need very rugged machines, obviously, and they were yet very vulnerable unless if you buy very expensive deep robotics or the very expensive version of Unitree or even a Spot, that they could basically be rugged enough for that environment. And the third reason was that, so what do quadrupeds give you? They give you agility in locomotion, right? So you can basically climb anywhere and go anywhere. But one thing that they take from you is the height that you might require. Compared to a humanoid, you have a human height, which in an application such as construction, for example, we needed to do inspection on a bit higher in the wall. And with the quadruped, it was very hard to do that. All in all, we solve all these with wheel-based robots. So wheel-based, we didn't see much more advantage of a quadruped over a wheelbase, which we could buy it with 10 times cheaper than a price. So that's what I think is one of the threats to quadrupeds application, that most of those applications can be solved by wheel-based robots. There are companies such as Drone Deploy or Energy Robotics that are trying to adapt. They're trying to take quadrupeds for energy grids and energy sector and oil and gas inspection. But even they got to realize that a wheel-based system could be much more reliable.
And I mean, militarily, also durability would be an issue, and then wheel-based or tread-based designs would probably be more stable if you want to put a cannon on top of it or whatever.
Exactly. We in this room know that the higher you increase the degrees of freedom and the number of actuators, the more vulnerable the system becomes. So now imagine something that you can solve it with 2 degrees of freedom with 2 actuators. Why should you solve it with 16? Or sorry, 12.
Mm-hmm.
So there were a lot of old school people. They were like, "Oh, what about the legacy ARM robots?" Because this is interesting.
We're called classical roboticists, not old school.
I was waiting for that.
That is true. Classical roboticists. That's a correct one. So and then there were a lot of from public. Many people were reaching out and asking, "Oh, so should we buy a Cobot or industrial arm, and what is the difference and so on?" And we thought, yeah, why not? Let's make one of these posters also. Funny thing, I mean, these are very big companies, right? They are just established big companies, most of them. And they also haven't really improved since the time we created this poster, which I don't know if I have the date here, but I think it was somewhere around 2023. And then one interesting observation is in this poster. This poster is representing 8 industrial robots and 8 cobots. Can you spot something here that might be interesting for you?
There should be a small Swedish flag next to the Swiss one on ABB.
You're on the right direction. Absolutely. But I should say that back in that time that we checked, ABB was owned 100% Swiss. But
those were the main companies, I guess.
Hexagon is still Swedish.
Isn't KUKA now Chinese?
Most of them probably are.
It's owned by Medea, which purchased them in 2017. But for the most part, it's all based in Germany. Just like ABB in my heart was never Swiss. It was always Sweden, because up in Västerås is where all it was. And remember the A in ABB is ASEA. And it's just that the corporate headquarters is down there. So it really kind of got that. But and now it's changed hands. It's I'm not sure. It's going to be interesting. What's the country going to be? Because SoftBank is buying it.
Yes.
But I think all the engineering is still in Sweden.
I was in a conference a few weeks ago, and one of the people from ABB Robotics were there, and he said, we are actually planning two big facilities in Gothenburg and another city in Sweden for ABB Robotics. So I'm sure the big part of it would be still in Sweden.
And ABB also has manufacturing in Auburn Hills, Michigan.
So I think,
which is just basically 3 miles from my house.
So Gustav said something about the flags and country, which was in the right direction. And now Scott also addressed, why isn't there any American robots?
Oh God, you want to hear that story?
Yeah,
I'm really curious. I don't know.
Do you have another Swiss company up there? I think you do. Stoible.
Yeah, Stoible, the third one.
That was the American robot company. That was the world's first robot company, known as Unimation. That was the company that in 1961 installed the world's first industrial robot in GM in Trenton, New Jersey. And they were the dominant player, like all of them. They owned the market for years. But they had a problem. And that was in the early days, a lot of the robots could not get enough power out of electric motors, so it was hydraulically actuated. At least the first 3 axes, and out the wrist they had something else. And so that's how the robots were. They were hydraulic. And everyone was like trying to move away from that. And they ended up having a big order that was going to Ford for some spot welding robots they were going to have. And Ford just didn't like the idea that they were like hydraulic. And the main thing is that hydraulics leak, and they actually have to leak. Otherwise, they're too stiff. And so they had these drip pans to collect the hydraulic fluid. And in this order, the drip pans cost $100,000. And like, you're talking about over 40 years ago or longer than that. So that's like a lot of money. And Ford was like, what? Are you kidding? You know? And so they finally agreed. He says, all right, we'll pay the $100,000 so long as it goes to R&D for an all electric robot. So it made it back to the board, and the board's reaction to that is like, why do we do that when we're making a killing on the drip? You know? So hubris. And so eventually, but Unimation was like the big one. That was the Americans invented it. And then, you know, there were a couple other companies that kind of came and went in the 70s. You know, Cincinnati Millicron was another one that tried doing it, and they ended up getting bought up by ABB. Okay. And then eventually Unimation, they came up with their electric arm, the Puma, but a bit too late, because you know who came up with the first all electric robot arm?
Kuka? No?
Nope.
Yaskawa?
I think it's like 1974, and it was
Mitsubishi.
Investora Sweden,
Mm-hmm.
ABB.
Mm.
ABB was the first all-electric robot, the IRBL6, the 5-axis robot. And you know who was the first one to buy it?
You?
No. Interesting story. When they unveiled it, you know, they brought all these people in, these, you know, presidents and CEOs of different companies to take a look at the robot that they had. And there was like a local farmer that was there, and like everyone was like, what's this good for? And he'll say, I'd take one. He bought it because you know what farmers do? They have a lot of work in the morning and they have a lot of work in the evening. In the middle of the day, they've got nothing to do. So what they do in their barns, they all have shops in there that they're just producing stuff. And so he was grinding. He was doing, you know, probably parts for Saab or something like that. And he saw, hey, this would be effective. And he took it and he used it as a grinding machine, you know, to basically hold the part and go in there and figure out how to do that. And then in the late 80s, ABB came out with like basically the replacement for it was what they called the IRB 2000, the IRB 2000. And it was referred to as like the world's first sexy arm because it was like all very round and stuff like that. And it's like, oh, the Swedish sensibility. Because if you compare it to like the Cincinnati Millicrons of the day, they were like, you know, the Terminator kind of bots, you know, all sharp edges and everything. And like, and suddenly they come up with this it's like, what is this? And of course, it was because of the eye towards safety and cables getting wrapped around and not getting caught up in that. So that was a replacement. And they wanted to get the arm back from him, you know, to put it in the museum because it was still working.
Yeah,
exactly.
And he didn't want to give it up. And so they said, but we'll trade you, you know, so they have it. And now if you go up into Västerås, you can see it's like right there, the original one that goes way back. So yeah, they kind of started.
Scott, you should write a book.
It's things like innovations like this. Oh, it's all on a Wikipedia somewhere. And that it's if companies don't innovate, they go out of business. That's how you lose your leads constantly. And so it was a little bit of hubris on the part of Unimation, and also the fact that sort of not quite the acceptance in the U.S. market for robotics that was happening around in Japan and Europe at that time. That was kind of the death knell. And then so they all got bought up. So and it's in fact Unimation is now Swiss, and Cincinnati Millicron they got bought by ABB. And so yeah,
but there's an argument here, although that Universal Robots is American now, or it's a while.
Yeah, it is. It's owned by Teradyne, so they bought them. But I think all the R&D, maybe the manufacturing is still done in Denmark. So it started as a data. So that's kind of interesting. That went the other way. But again, that was like that's another explosion in industrial, because industrial robots were moribund. They weren't really going anywhere. And then the Cobots came out. That changed the scale factor, and that's easily half the robotics market. The big incumbents ignored Cobots for years. They thought they were a joke, they were toys, they weren't going to go anywhere. And so they were not doing it themselves. They were kind of looking over and saying, what you are doing. And then you started getting a lot of these startups that were doing it. And then the big boys just started to buy them up when they could to bring them into their portfolio. So a lot of it, that's how they did it, is through acquisitions. When they realized, hey, this is the thing, we need to actually get into this revolution as well. And you'll see that there's a lot of them. But you're right. In many ways, some of the arms you see there look very similar to the ones I was starting to simulate back in the late 80s. So, but the mechanics have improved. The motors are a lot better. The gear drive's a lot better. From the outside, they look very similar, and it's a very, very slow, because at this point, there's very little room for improvement, and we know how they work, and a lot of it's just driving the cost down.
To be honest, this is the story that I can predict for humanoids also. Like, we are now talking about all these humanoids, but the fact is, right now there are a lot of companies making very big, huge monies by just trying to adapt the cobots and industrial arms to certain applications, welding and like more creative applications. But humanoids are not there yet. We are still building the skeleton, right? We are still contemplating on the number of actuators and the order of actuators. But when we have passed this industry maturity, it would be the time that now we will think about application. So maybe it's too early to think about application. Learning from industrial.
But what I think is going to happen is that rather than the robot incumbents saying that we're going to wait for someone else to come up with a humanoid that's really good, and then we'll buy it, because they're not doing their own internal R&D programs, which you think they would be, it's going to be too late. Because unlike the cobots, where those companies were not very profitable, or you could buy them really cheaply and just kind of fold them in, you can't. Because look, ABB, how old is it? Just a robotics division, and it sold for less than $5 billion. And again, it's not a question of whether it would have gone, maybe it would have gone for more or less if they actually had spun out like they wanted to. And then if you look at the valuation of these humanoid companies, the valuation, I think a figure is worth like all of the industrial robots capitalization.
Wow.
Just like Tesla was worth more than all the automotive. So it's just like,
that's great.
If anyone's buying anyone, it's going to be the humanoid companies buying the IR company, not the other way around.
That's
so
true.
What do you guys, Scott, since you're the factory simulation expert, what do you see the future of factory floors like? And it's going to differ from sector to sector, of course. Like for electronics, you'll probably not need one of these cobots that you would use on an automobile factory floor, right? But how do you see this coupling between cobots and humanoids moving forward?
Okay, so everyone wants to have the lights out factory. That is just the absolute dream to be able to do it, which means you have to figure out how to automate just about every single process in there. Cobots were supposed to be that middle ground of like, oh, we can make industrial robots do the things that people do. And they just didn't, they came close, but not there. And they may get there because people are saying the problem with the cobots is they just weren't smart enough. So let's give them some AI, let's give them some cameras, and let's give them some better end of arm tooling. And maybe that's all we need. We don't need a humanoid form factor. And the more and more you can do that, the more compact your factories can become. So a lot of the safety guarding that you have to have that screens the industrial robots off from humans, that can start to drop as it's being taken care of with other equipment that's going in. And then you can start thinking almost three-dimensionally, because a lot of the spaces that we have in the factories are designed to make sure people can feel safe in there. Temperature, humidity controls, all these other things, breathable air, adequate space, all that stuff. But just imagine that people never have to go in there. It's like, the printing press. If you think what a printing press used to be years and years ago, going back to Gutenberg, I got one sitting over there. I cannot get inside or anywhere near that. It's just so compact. Everything you need is there. There's no space for a human. So you could almost think of the same factory starts getting compressed down, that all this volume that's there because we need to have walkways for humans and we need to have break rooms. We need to have all this other stuff, just sort of disappears as it comes on down because you're not worrying about that. And the form factors may start to get rather interesting, like big humanoids, small humanoids or something like that, or maybe not humanoids. We don't know what it's going to look like. So I think, in a word, alien dreadnought. That's what it's going to look like.
Vision.
Yes.
Yeah. Speaking of which, it's rather topical to ask you this. What do you make of the Trump administration's discussions with
about robotics
leaders in the bot industry?
It's long overdue. It is
right.
absolutely long overdue, because China already started that program a long time ago, and everyone has said that the U.S. kickstarted the whole humanoid thing with the DARPA challenge back in the early 2000s.
Right.
And it's time for a second one. Jeff Cardenas from Aptronic has been saying, we've needed that. We needed that national mandate to move it ahead. So it's a step in the right direction. And, the press reports are very brief. I haven't been able to see too much, but I know people were discussing something to do that. There's two ways. One, we need to get the industrial humanoids. Let's focus on that. That should be part of it, but not the only focus. We have to look at the reindustrialization of the U.S. by bringing in the industrial robots, the current solutions we have right now. And right now, the return investments aren't there for a lot of companies. And part of it is because the way the tax laws are written, they really don't see the benefit until later on rather than upfront. So if there's some upfront incentives to start getting more of these in the door, then people will take that step, because right now it's a risky gamble. So things like that, I think there's a lot of things that can actually be done, the incentivization. The other is that once that market signal gets out there, people start realizing this is the industry of the future. This is what they want to do. Right. It's not that we don't have enough industrial robots, or we don't have the capacity to be able to build them. We don't have enough integrators or enough people familiar with it to actually be able to do the job. So that's the thing that's always slowed it. It's what they call integration hell. Is it going to be
easier for greenfield projects, or do you think?
Oh yeah, I think it would be.
Even for brownfield, where you have existing
also brownfield. I think a lot of brown because that's where it's going to be. Is we have a lot of corporations and small companies that are trying to figure out how to improve their output and efficiency, and so they're ready to bring in this automation equipment. They just are afraid of making that step. So a lot of it is going to be brownfield, bring in quickly. And then the expertise is what's just kind of been lacking, because everyone's just thought, oh, robotics is boring, or, it's just a small subset. And now everyone's realizing, hey, this could be like an interesting career choice to kind of go into. And that will help. So in government can lead a little bit by example. It doesn't have to be huge handouts or anything like that. It's just going to be a good policy.
My next question to you, which is what are the real incentives that the industry needs from the government, from the Trump administration? Is it on energy? Is it on technology? Is it on imports? What sort of support really does the industry need?
You're just talking about in general for the robot. Energy would certainly be for the AI. That's going to be a big problem, making sure that's solved. But the other is that starting to have more of a homegrown robotics industry, and that so many companies sprouted up over the past 20 years creating robot arms, except in the US. And why is that? It's happening in Europe, it's happening in Japan, it's happening in Korea, it's happening in China, it's happening in Brazil, it's happening in India. But then I'm looking around and so why isn't it happening here? And so we have to address that problem.
So you've got like energy. What about supply chains and dependence on China? Because it seems to me that the Trump administration has really kickstarted things after it's come in. We've seen some important announcements, white papers, if you want to call them, since April this year. We've seen the Chinese government talk about their 2025 plan, the new plan to go all in on AI and robotics. China's also looking at Europe. It seems like Europe is somewhere lost in all of this, Scott and Mehrdad. What do you think? And Gustav also.
There are a lot of flags from Europe in your chart, but will they stick around?
But that's for Cobots.
Yeah, the Cobot, but there's a little bit of hope because you see Humanoid coming out of the UK. You've got Neura in Germany. You have Agile coming there. You've got other couple of smaller companies. I think Aegis is doing it, and then of course the big one, the announcement this week, UMA coming out of Paris, and I think there's a few other plays that are going to be happening also around Paris and in France as well. So it's starting to move a little bit. I think the signs are there, but there's a lot of catching up that has to be done. And I'm sure there's still some policy changes that people would like to see at the EU level. The thing I keep on hearing is like everyone that's tries starting up in Europe is like, there's no money. They cannot get the venture funding. And if they come to the US and suddenly they're able to get it. So, and there's probably a variety of reasons for that.
Yeah, because it's Mehrdad, correct me if I'm wrong, but this is strategic depth that China would love to have. If China can supply the bot labor for Europe, is no better strategic depth than that.
You know, one thing I've realized, maybe it's specific to Swedish mentality, but is that Europeans has always been very innovative, but if it doesn't make financial sense or if it have any risk or something, they drop it and it becomes a winter in that area. But one thing about Swedish industry is that Sweden has always been the smart followers. You know, this definition of smart followers in the Tour de France cycling. So they haven't been the first in the row, not the second, but the third or fourth. And then because they let others to break the wind and then they follow.
Yeah.
And then when it's the right time, they will kick. So that's what I predict also. So they are letting China and US to try and play with the technology and see how it goes. And when the right time comes, as Scott also mentioned, they are appearing. So I don't think if they will be left
Can
behind.
we afford to do that in this industry?
That's a good question. It's also like a lot of legislation and policies by EU being put on all the systems. So, well, one thing that we need to remember about both US and China is that it's a good, there are good countries for producing, and also there are good consumers. So in Europe, it's like the consumption part is a bit questioned, at least in the past years. But I don't know. It's not my specialty, so I would rather not talk too much about it.
But my point is, even if you look at, I mean, let's assume that that's what Europe is doing, right? Letting China and America lead the way and then being smart in the way that they follow. At the end of the day, even for America, Scott, there is a great amount of dependency on Chinese supply chains for rare earths, for small little motors or little pins that go into the actuators and stuff like that. How in the world are you going to compete without building all of that capability onshore in America or Europe, for that matter, if Europe does want to play catch up?
You do have to build a lot of those supply chains, but you don't necessarily have to have them all. You can. There's still a lot of things that you can begin to build locally that maybe are going to external supply chains, but at least you're starting to bring it onshore. One of the things we keep on hearing in the US is like, what about shipbuilding? It's like, yep, that's something we we gave up decades and decades ago. And then the only shipbuilding we have is for defense. And there's a resurgence in there. And while there's certainly a lot of components that go into a ship, the big thing is like building the hull. And all you need is steel and welders. And the thing is, we don't have the welders, so everyone's thinking, well, how do we do that robotically and start to bring some sort of automation? So you can do a lot of that, and that's a lot of value add. So again, don't go for the 100%. Go for the low-hanging 80% kind of stuff. That may be a lot of it, and then eventually you can start looking into those supply chains, and you might say, hey, you know what? I think we can do this. It doesn't look that hard, and someone's already got the manufacturing experience, and you just kind of build up from there. But and then what I think will happen is that trade and everything will end up kind of evening out right now, because everything is like this big ripple that's going through and everyone's trying to figure out who needs to do what. Markets are best when you take advantage of what everyone else does best. And that sometimes realizing what your strength is something else. So sometimes there's distortions going on in the market, but once that market gets kind of settled out and everyone agrees this is the playing field, then you might say, we don't have to have do everything internally. We have enough trading partners that we can work with, and they can't do everything either. That's why they have to depend upon us. I mean, not every country can produce cars, they're just not big enough.
Yeah,
but they might be able to produce a small component of it, but at some point they have to import cars from somewhere else.
True. I mean, speaking of shipbuilding, look at what happened to Glasgow and Scotland and the entire shipbuilding industry there, and that I think is a lesson to be learned as well for America. So I don't know if it seems the rate of progress of these industries is very different today than it was decades back, and to me that is the main looking at it from the outside. That's the main challenge. How do you catch up where there's already so much of money and resources gone into these industries in China and America, for example. All right, let's get back to your slides, Mehrdad.
Yeah, I'm supposed to talk for 35 minutes, so I'll try to
carry on. We took a bit of
Detour.
Turn
As
along
we
the
do.
way, a detour along the way.
No worries. So this was the story of Cobots and industrials. And then after this, we had our grand poster that we were thinking, okay, we don't have a proper categorization. The reason was I sometimes just, as a guest lecturer, talk in University of Chalmers here. And then whenever I want to talk to the students, I wanted to show them what are actually how do you distinguish these robots? It was a very hard job, basically, to explain it based on the existing categorization. So we thought, let's make our own. And here on top, you can see the difference. Let me see, I cannot zoom here. You can see the different form factors, and on the horizontal axis and on the vertical axis, you can see different industries. But the point of this poster, for us at least, was that this pink thingy on the bottom of the page, that we could find a saturation in the market, saying that which part of the matrix axes are saturated and which parts are not. The white dots are almost non-existing. And because it doesn't necessarily make sense, to be honest. It doesn't make sense to have a soft robotics in service industry, or having a AUV, like a underwater robot for, I don't know, healthcare and medicine. Maybe it does make sense, but we don't have it by today. So this was kind of the purpose of this poster. And then, yes, so like often people actually print out these posters, and they actually ask a lot for printing. And this could be an industry for itself, actually. If somebody's into it, they can just print out these posters and sell it. We have open sourced it, so it's fine. And this is Bowen from...
I think a lot of classrooms and schools should have these posters to inspire the kids.
Yeah, the problem with posters, at least in this industry, is that they go expired very quickly, right?
Yeah.
So then it's very hard to update them. But Bowen is from Philadelphia, and then his father was working at SoftBank Robotic, and he reached out to me and said, hey, Bowen loves robots, so can you send us a print? I said, no, we don't print, but I can send you a high quality photo for print. So there are a lot of people interested in just printing it, apparently. And this is our latest humanoid poster. So we decided to update that 2023 humanoid, and a lot of changes. And that's one of my points, actually, comparing cobots, quadrupeds, and social robots. We had kind of the biggest boom, from my perspective, in more like, I don't even know how to call them, but more like, let's say, humanoid robots, adult size or kid size, that are mostly targeting end consumers, and not in a sense for entertainment and research, but for actual end consumers. And this was recent, I think, this poster, and also got a lot of attraction. And the other interesting observation here was that, as you can notice, sometimes we actually remove some of the companies. For example, we don't have Menti Robotics here. And then that's because we didn't really see so much progress from them since 2 or 3 years ago. So we replaced them with other robots. Yeah, that's about it. And now I want to show our hand poster.
Drum roll, please. Here we go.
It is.
Is this the first look that we're getting at this?
Exactly.
Wow.
It's the first one. So we have 21 hands here, and some of them are familiar. So the top row is humanoid native hands.
One for each degree of freedom.
Exactly. It's also, Scott, you told me something before, that how do you make sure the numbers fit in the so we had a hard time there to drop 5 hands, but it is still very impressive to see that we have 26 robotic hands, maybe in the past 5 years. Some of them are a bit older, like Shadow Robotics has been around for a long time. Most of them are like within the past 5 years. And so we had an issue here, and the issue is, so we have humanoid native hands, and then we have open source hands and independent hands, such as Kepler that you talked about.
Can you define humanoid native hands for my audience, please?
Yes, absolutely. So it basically means that a hand that is made specifically for a certain humanoid, such as Sanctuary, they made their hand for one robot. Tesla, they made their hand for on robots. So
you can't buy it, basically.
Exactly.
You have to buy the whole bot. Yeah.
Exactly. You can't buy it separately. And then we have a bunch of open source hands. And then we have this interesting category or a market move that a lot of prosthetic hands has entered robotics. They have sold their hands. A good example is psionic. There are a lot of humanoids that are using psionic hands. And it was a prosthetic hand originally, but then they repurposed it for robotics. And then lastly, we have the purely prosthetic hands, but I talked to a few of the founders there, and they said we've had tests on humanoids and other type of robots. So and that was the hard part, to be able to categorize them. And we even actually were thinking, should we even include the prosthetic hands or not? Then we thought, yeah, some of them are pretty notable.
What are the advantages of prosthetic hands in the humanoid industry?
Let's ask Gustav also.
They exist, I guess. That's the
They
first thing.
exist. I mean, and
The reason I ask you that is because we've in the recent past we've reviewed and analyzed and broken down a lot of different form factors of devices that are used to gather training data. The Sunday glove, the Sunday bot glove was a case in point. We'll soon be talking to a very interesting company out of Italy that has a bionic prosthetic, and then you obviously, Mehrdad, there's the whole range of prosthetics that you have on this poster. When you compare that to let's say something like a Boston Dynamics, which is 3 digits, or other form factors and other devices for gathering training data and teleoperation.
I mean,
what are the advantages?
I don't think you would get the training data, because one of the main issues with the prosthetics, why many of the humanoid bot companies aren't really interested in the prosthetics, I think, is that it's too few. I mean, there are a lot of people who would perhaps need a prosthetic, but they are not enough to collect data. I think the ones who actually use them today, they are available and they are compact in their design. Most of them, you connect them to some kind of casing that you have, but the motors are all, or the actuators are all in the hand on more or less all of them, and they are durable, I'd say, compared to many of these prototype hands that we see. So I think they would probably last. They are built to be able to be used in quite rough situations. So then, of course, you have the more aesthetic prosthetics that are not really meant to be used, but the ones in the picture here are, I would say, more durable and more the ones that you would use when you go to the garage or whatever. But is there any differentiation in where they are actuated in your humanoids, for instance? Like you have the tandem-based, and then you have like the ones that try to go for actuators. Because
so that's what I wanted to explain. First is that in this poster, we try to focus on dexterous hand. So there's no proper definition for what is a dexterous hand, but we put the definition of ourselves. We said less than 6 degrees of freedom is not dexterous. And we have good reasons for that. And so and also 5 fingers. Well, we have 4 fingers that are pretty dexterous, but we thought 5 fingers is a criteria, and also 6 degrees of freedom is a criteria. And then we have.
Can I just stop you there?
Absolutely.
For those in my audience that don't understand what a degree of freedom is, please explain briefly.
Absolutely. So a degree of freedom is an independent movement of a joint in the plane. So basically, when you have, if we consider this as a plane, then this motion, which is independent from this motion, could be considered 1 degree of freedom. In most of the robots, some of these motions are connected to each other, meaning that when this one, for example, turns, then this one also turns together with that, and the last one also together with that. So that's how we have 2 numbers actually under this hands. One is the number of joints, and the other is degrees of freedom. As an example, one hand that I can mention, don't have to mention, but it has 6 degrees of freedom, but it has 21 joints. So a lot of them are just connected to each other. And of course, Gustav and Scott are also expert in this here. But that's basically the idea behind it, excluding the wrist. In almost all of them, we excluded the wrist. There was another question Gustav asked, and that's also very important. What is the system? What is the mechanism or architecture? How do we include that? We included that in a tag under each hand, saying that this is tendon base, this is electromechanical with linkage, this is hydraulic, and then I think that those were the main ones, these three different systems. I don't know, Scott, is there any other system?
It could be like a hybrid. Is that you have some that are half tendon and then half linkage mechanism. That's one possibility. And then,
Exactly.
Hydraulic pneumatics. I mean, I guess we would kind of lump them together.
Yeah.
But there's probably going to be others, but pretty much people think of tendon base, or they think of some sort of linkage direct drive, and then the hybrid will just be something in the middle.
Exactly.
Can't think of anything else.
Yeah.
Well, then the other is like direct drive. So I think the third one is that if you look at the Sharpa hand and look at the Wuji hand, they're kind of direct driving the joint, but with a micro drive, sometimes directly at the joint. So the actuator is the joint. In the other cases, the phalanx or the bone is made up by the actuator, which is what the Wuji hand does. So I think that's like kind of another category.
Yeah. Sorry, Mehrdad, you wanted to say something? Finish your thought, and then I have a question for Gustav.
Yes. So the last thing I wanted to say, thank you, Scott, for the clarification, is that one point that Scott was saying regarding prosthetic and adaptation in robotics. I talked to a founder of one of the prosthetic hands, and she mentioned that our hand can operate individually. If you cut it from here and then just connect it with some wires, it's fully functional. But most of the robotic hands are not like that. You either have the mechanism or motors in the wrist, or you have, I don't know, in hydraulic systems, you have a hydraulic or something else somewhere else. So that's a big difference. And then the second big difference is the durability, that the same person actually, and another founder mentioned that if you put these hands 10 meters under the water, it can still operate. And it was interesting for me when looking at the
what
photos.
rating is that? What IP rating would that be?
They have restricted the standards for building those, and that's what I like about prosthetics versus robotics. In robotics, they just want to explore. Robotics is just this child in the family, usually the last child that is very spoiled, and nobody expect them anything, and they can just do whatever they want. But in prosthetics, they have like restrictions and they have regulations, and there is an insurance on the other hand that is checking all this, so they have to comply with all these things. So prosthetic hands seems more reliable, but surprisingly less degrees of freedom and less capable. For example, of course, you have tactile sensors there.
What's the reason for that, you think? Because
Sorry?
prosthetics have been around for a while now, a lot longer.
They have been, exactly, and because they are very human interactive and they are very regulated under medical regulations.
Yeah. So why is there less complication in the prosthetic, in the most advanced prosthetic hands as compared
less
to
reliable, right? Because less reliable, and it's the weight also. So there's a regulation for the weight. I'm not sure exactly about the number. I think it was maximum 800 grams or something should be the total weight. If they go beyond that, then it's. I mean,
that's for the full hand, the forearm and the wrist and the palm.
No. Only the wrist, only the hands.
Oh, okay.
And then the other reason is that this complexity that they add is extra power needed, basically, which is something in robotics we usually don't think about, but in something that human is going to carry, that's something pretty important.
And I'm not that well versed in prosthetics because we only have a few patients ever with them, but I would say that the majority of them are just flex extend when it comes to the digits, and the thumb is usually not opposable by a motor. You actually put it in this position and you do certain kind of grips, and then you manually snap it into an opposed position, and then you do your tripod or your power grip. So I think some of them is electronically, but then it usually locks in that position, because the problem also is when you the more degrees of freedom or varying grips, you have to control it. And we are more or less, we are only controlling open and close in these patients. It's really hard to train them to do a multitude of tasks when you only have a few muscles that you can use to activate it with your myoelectric controls. So I think most prosthetics, they go for open and close. I did the opposite there, open and close. And then if you continue your close, for instance, you would do a different function. So I think one of these hands, the Kobe hand, has like a spray bottle function. So when you close, it would put it in a position. And if you continue the closing action with your muscles, then it would kind of do the spraying action. So it's very, there are, at least so far, not very many AI-driven prosthetics that are like
that was my next question. We've heard Elon talk about Optimus hands and legs.
Yeah, and I mean Neuralink. In theory, Neuralink will solve these issues if you could get a really, or I mean, you would be able to solve it with Neuralink.
So, in your experience, Gustav and Mehrdad and Scott, is this how does it work? Is it work through Bluetooth, the connections, or is it
no, it's myoelectric
into the neuro
EMG, right? Electromyogram.
Yeah, so you have like a sensor on the skin is the most common one, and then that
captures the signal,
collects your muscle activity. So you need to have functioning muscles somewhere. So that's the common version. The problem with that is if you have like sweaty skin or dry skin, the contact will be worse. So there's quite a lot of research doing intramuscular implants that kind of sense the signal instead, so you don't get the skin in the way. It's directly into the muscle. And there are also those who are directly intraneural, so that when you activate the muscle, it collects the signal from the nerve instead, like in a sleeve around the nerve or something else. So it would be a more direct control. And we have some colleagues in Scotland who kind of implants really small, like pill-sized controllers into your muscles, so they collect the signal and send it to the hand. But I think the most common is just a wire with like a skin detector looking similar to like your ECG pad that you put on the skin to kind of control. And that is, I think, one of the main issues is that they are really hard to control in a natural manner. So people just remove them because it's complicated. And as we saw in a video like a year ago with this shoulder strap design, which is more like movement, they are a lot more easy to learn how to use and grasp things than this myoelectric.
So the human body is more adaptable and
because the connection is not good enough yet. But I mean, if you have a Neuralink that you can control it with directly, then in theory you would have more output controls instead of just open close. You could perhaps have up, down, left, right, open, close. Like you could add more signals to the hand.
Right. And you could have your hand operating independent of your body.
Yeah, so there are these videos of this girl with prosthetic hands who puts it on the table, and then she kind of controls it with the EMG controller in her sleeve. So the hand is on the table, and she makes it kind of walk on the table by controlling Adam's family style. So that is possible, of course. But I think that is, they are not durable, or they are durable because they are simple in their design. But hopefully the humanoid bot race will kind of develop the prosthetic field by.
Yeah, I mean, for a casual, someone who's casually tracking the humanoid industry, the immediate question, I suppose, would be, well, if you've had prosthetics around for so long, why have they not been, at least in the beginning, used more for teleoperation of humanoid bots and that? Well, what's the reason? What's your response to that?
I can say like they're inherently different architecture system than a robotic system. We talked about it before, I think, but one of the most important things in robotics is control. And if the control architecture is very different in a different system, it's very hard to. I mean, it's just easier to build a hand from the ground up than adapt an existing one. Also, when we talk about control, like this, Giovanni, the company you want to talk to, Bionti Robotic, I hope he corrects me if I'm wrong, but their hand has only 2 motors. We can say.
I think it's only one.
One, okay. I saw on their website it was like 2 motors, but they did something very smart. They used a
I may be wrong, but
mechanism which 2 of them moves together or something like that. So they kind of had a mix of motions. And that means for a robotics project, having differential mechanism here, it makes it very hard to control a dexterous manipulation task. But of course, there were cases like, for example, Psionic was very smart here. They moved very quickly to humanoids, to robotics, and then they could adapt their hand to that. But yeah.
Okay, cool. All right, let's get
Yeah,
back to
that comes down to the whole thing of you can have lots of joints, and then there's degrees of freedom. And if you have only one or two motors, then you just don't have the control because all the joints are kind of moving together. So in order to get that dexterity, and that's probably been the difference, is that if you want to come up with a prosthetic hand and you've got all these constraints, and you have to go to the minimum viability. So it has to be an MVP, the absolute bare minimum, to get the mass down, to make sure it's durable and everything. So it doesn't quite have the functionality that the roboticists would like to see. And of course, the roboticists are finding out the hard way that when you start putting that functionality in there, it's really hard, and that durability and all these other things come in there. But you really need to get the dexterity. And that's why the difference between joints and degrees of freedom, why we talk about this all the time, and why it's important that poster does make that distinction, so you can kind of know. And it's almost, but not quite, you can pretty much think of degrees of freedom as like the number of actuators you're going to have. There are kind of some exceptions in there, but basically that's what it's coming down to, is you can almost think of it, that's your motor count, and the other one is your joint count.
When it comes to the prosthetics, I think it's mostly grip types they are considering. And it's like, is this a power grip? Is it a key card grip? Is it a tripod grip? So that the patient has different options in everyday life. And the same, like a pointer, clicker grip, whatever that is, it's the same that controls the mouse, and the same that you would push on the computer and push a light button or whatever. So I think it's more grip or interaction types instead of just controlling individual fingers and thumb.
Cool. All right, let's continue with your beautiful poster.
So that was mostly it, actually. And here I wanted to just have a comparison, saying this is a prosthetic hand, this is a robotic hand. Both of them are very native to its own core. One thing visually we can see also is that prosthetic hands are usually very much waterproof, and very much in the design they really try to not show anything of the mechanics and so on. And the other observation, which is a bit based on the information, is that very few of them are tendon drive, almost none. They are mostly just direct link, direct drive, or electromechanical linkage, and no hydraulic. So it seems like in robotics, again, we have a lot more room to explore how things look like. But
it's kind of ironic that the prosthetics are trying to imitate robots, and the robot hands are trying to imitate people by going more tendon-based. Now, let's go to your poster for a second and see if you can check something. I don't know if you saw the humanoid announcement yesterday, where they showed their bot walking, and they also showed their hand. Is their hand on the poster? Because I suspect it's an off-the-shelf hand, and I'm not sure.
That is a very, very good question, Scott.
I think it might be down there, but I'm not sure.
I have a hunch. I asked a few people; they haven't answered me yet. But I had a hunch that it is. Sorry, I need to check the name here.
Is it on your poster or somewhere else?
It is on the poster. But
okay. I suspect it's down the bottom, a little bit to the right.
Yes. So
now they said, and this is so, Gustav. This is like the mystery. Their hand is a 12 DOF hand. Okay, so what do you think the 12 degrees of freedom?
You're going to make me count again?
No, it's actually joints, but yes. So I'm going to make you count again. No more filibustering. Let's go ahead.
Okay, so if they have said 12, then
they only have one.
Yeah. Usually you think of like 11 or 16 or something like that, but 12 is an interesting number.
So they only have one IP joint, then, I guess.
One IP joint, yes.
Yeah. And then the MP joint with flexion, like 2 there. So 8. But then I'm already at 12, so that can't be right.
12
or do you mean that? You mean joints?
You've got 8 here on the fingers, right?
Yeah.
Which means we've got to come up with another 4. So you're looking at the thumb. The thumb also only has one IP joint. So that means, well, the CMC joint must have 3 degrees of freedom in there. But why would you put 3 if you don't have enough? So the thumb has 3. And when I actually looked at it, the answer is really here. You will look at it in one position. You will see
Oh yes, yes,
Yeah.
the index that can abduct. Yeah.
Only the index finger abducts, and the others stay parallel. So that's where they snuck in the 12th degree of freedom. And if that one on your poster is 12, it probably is.
Exactly. So I'm just waiting for confirmation, and I'm not gonna say anything now.
Okay.
But one of them actually just probably will answer soon. We will see. But I have the same feeling as you. It's a third-party hand, and it's not one of the most famous ones, but it's one of the very niche ones. Let's see.
Okay.
I should also mention for the information in this poster, we got a lot of inspiration from your post, Scott. Thank you very much for all the analysis.
Oh wow!
So especially when I was talking to some of the CEOs of these companies, they had no idea about the number of joints. That's the only number that they usually are like, oh, not sure. There was during one of the meetings, and the CEO was like, okay, let me count it. I'm not sure how many. They don't have this number necessarily. So degrees of freedom is very common, but the number of joints is, it's an important number, but they don't.
And it even comes down to, as we've talked about, this big discussion of how many degrees of freedom does a human hand actually have? And the argument between, well, we can nitpick and say it's got like this number, but what's the useful number of degrees of freedom that you really have to do a variety of things?
Wow, this has been a brilliant chat, gentlemen, but it's been wonderful. So enriching, so enlightening. It's such a beautiful learning experience talking to you always, gentlemen. Thank you so much, Scott, Gustav, and Mehrdad.
Thank you
Such
very
a
much.
pleasure to have you, and I can't wait till our next chat.
Yep.
Thank you.
Okay. Thank you.
Take care. Have a good day.